Okay, great. Thank you. Thanks, Saurabh. Okay. Hello, everyone. Please give me a confirmation if all of you are able to hear me loud and clear. Okay, great. Great. So, excited about learning R, data science with R, right? All of you are excited. So, what are your expectations uh, around uh, this training? Can you just some of you maybe put your expectations in the chat window? What do you expect uh, to be uh, thorough with or to have after you complete this training? Yes, anyone? No one. Okay, great. Be able to tackle real life problems and make informed business decisions using R as R to analyze data set. Okay, do we need to know R language beforehand? Not at all. You will be learning R language in this, right? Being a non-IT background, I need to introduce with R with ease. Okay, great, Sahu. Just to give, how many of you are from non-IT background? Type NIT. I got Sahu, right? Okay, Deshmukh, Sahu Deshmukh. Okay, a lot of you. 1, 2, 3, 4, 5. I can't even count. 6, 7, 8, 9, 10, 11, 12. Okay, at least half of you are not, right? More than half. Now I'm getting. Okay, so just to give you a comfort, I may have started with data science like almost 8 years back, but I'm also a non-IT. Okay, I'm from a non-IT background, so and I am a data science trainer for R, Tableau, SQL. Also, I know Power BI, and yeah, these are some of the technologies I specialize in. Right. So this is just to give you a comfort. It is not just remove that mental block from your mind that you are from a non-IT background. Open your mind that you are here to learn something new. How many of you are coming with a learning mindset? Type L. If you are coming with a learning mindset, type L. You want to learn something new, right? All of you. Now I'm getting far more else, right? So all those who are ready to learn, it means you are coming with an open mindset, right? Yes, you all of you are coming with an open mindset. And let me put this upfront. Learning, okay, tell me, learning happens in dash zone, comfortable zone or out of comfortable zone? When you are out of that comfort zone, let's see if anyone says learning can happen in the comfort zone. No one, right? Let's be true to yourself, right? All of you agree? Those who have replied and those who have not replied also. All of you agree? So, so be ready to be out of the comfort zone and be ready to learn with the open mindset. These are the only two things I will ask you. Rest, I'm not saying it will be a cakewalk, but yes, you will be able to do it. And you will be able to do it. This training will give you a very good foundation. See, R is open source. All of you know what is open source? All of you know what is open source, right? You don't have to buy any license. Just download R Studio and you are good to go. And second thing about open source is Google is God, right? What is this? Why did I say this Google is God? Because tools that are open source like R, Python, Orange is one data visualization tool that is open source, right? Then there are many, especially with respect to data science, right? You can get everything by searching on Google. Even when you're stuck somewhere beyond these training, right? Once the training is over and you're working, you're practicing, you are working on a project and you get stuck somewhere, Google it. Everything is there. So Google is God when it comes to open source. Remember these things. I usually start these training because more than half of the audience, more than half of the learners I get, they are from non-technical background. And yeah, Stacksflow, that is one. Stacksflow, R bloggers, then YouTube, lot of content is there. And the R community is so huge that they keep on contributing. And another thing, learning an open source, right? Okay, I was just speaking something, and yeah, I read Stacks Overflow and I just got distracted. So what I was saying is that learning an open source, Google is God. So whenever you're stuck somewhere, even beyond, and you're learning even beyond this training, and believe you me, once you have a good foundation, right, then it's up to you how, to what extent you want to learn that software or learn that tool. There are something called packages, right? In R, we have packages, and each package is specialized to do an activity, right? Do any particular functionality, right? For example, for data analysis, base R can do data analysis, but there are some specialized packages like dplyr for creating visualizations. Base R can create visualization, but there are packages like ggplot2 which create far better visualizations. Similarly, for doing decision tree analysis, there are packages, there are specialized packages. For doing clustering, there are specialized packages, right? Doing regression, there are specialized commands, right? So what I mean to say here is, and anybody wants to take a guess how many packages are there in R? Maybe you can take a guess. If you don't know, just take a wild guess. Don't Google right start away. I mean, right at the start. I know I said that Google is God, but yeah, I just want you to take a guess. Okay, Gaurav said 50. What about others? How many packages are there? More than 100? Okay. Let me not sure. Okay, fine. I know all of you are not sure. I'm saying just take a wild guess. Okay, Bindu says 2000. Let me see who can come near to 200 plus. Okay. Okay. Only these responses? 10,000. Okay. So Pradeep is nearest, but still 50%, approximately 50% to the number of packages that are there in R. 18,700 something packages. Do you think it is humanly possible to even remember the name of these packages? Do you think it is humanly possible? No, right? But still, R is one of the favorite tool not only for the researchers but for data scientists also. So how do you manage that, right? See, learning an open source is like looking for pearl in a ocean, right? When you learn an open source, right? I'm going to make you independent. I am going to start handholding you from session one, but as you reach the last session, I will make sure that you become independent. Now, when you become independent, suppose just think the person who looks for who's a professional who specializes in looking for pearls in sea, right? Do you think he boils down the entire ocean? No, he does not. I mean, empties the entire ocean and then get the pearls, right? That is not what we are also going to do. you should be knowing how to reach out to the right packages. And just to give you an idea, which I'll be definitely showing it to you, every day these number of packages keep increasing. Sometimes some days are like that even 100 new packages get published. Sometimes no packages get published. Some days are like even 100 packages get published. So what I'm saying here is, as an open source expert, you will also keep a track. Where do you keep a track? From these communities like R bloggers, Stacks Overflow, and there are many other websites, right? Our official websites are there. So keep it. You once you learn R, right, and you start using it, right? Then you start keeping a track of, okay, what new packages are coming, whether this new package will make my work more efficient. You'll probably read a summary of it, and if it makes your work more efficient, you'll learn that. But it is not that you will, of course, not possible to learn even the names. So forget about learning 18,000 plus packages, right? But what you will be learning is like how to pick up the right packages when needed, right? You cannot, in an open source subject like this, you cannot cover it in 40 hours, 40 odd hours, right? But yes, you can become confident that you will be independent enough to handle. How you can become independent, we are going to learn this along with learning the content that we have to cover. Okay. Yeah, that's what, Ranjit, that's what I'm saying. How we will be determined, that's what I'm saying. We'll learn where can you find how can you find those packages, what these packages are doing, right? Which are the best packages, right? How can we find those packages, and then how can we learn those packages, right? That is what I'm going to simultaneously, as we cover the content, I'm going to sensitize all of you about that. Is that okay? Does this small introduction give you a comfort level, especially people those who are from non-IT? Yes? Yes, it gives, right? So on that note, let's quickly, I'm going to just introduce myself. Okay, I think my, wait, I think I was not given the presenter rights. Just a second. I think I'm not given the presenter rights. Just give me a minute. Saurabh, can you hear me? Saurabh, can you hear me? Uh, who is this? Mithunya. Mithun, right? Mithun, right? Mithun, that's what we are going to learn, right? Right at the first hour. Today we are not even going to touch R. Okay? We are not even going to touch R. We are going to learn the fundamentals of statistics today. Okay? So tomorrow, in fact, not tomorrow. I don't know whether you are aware of it. Tomorrow I am not available. Day after tomorrow, when we'll have the next class, next session, we are going to open R, and then how to use these packages and all we will learn. Okay. I think I'll have to ask the learning success manager to give me the presenter rights. Just give me a minute, right? We'll be just starting in a minute. Okay, great. So let's start. Okay, Mithun, just to give you, tomorrow we will not have class, and we'll have a extended day, right? In the end. Okay. It will get updated. It will get updated in the LMS. Don't worry. Okay. Okay, Mithun, just to give you a partial answer, what do we use these packages? I just started with that. That package, each package is used to do a different task, like data analysis, like regression, like not regression, but regression is done from base R only, like decision tree, like data visualization, right? So every package has its own specialized task that it can do efficiently. Okay, so let's get started. All of you can see presentation, right? All of you can see this presentation. Quickly, I'm going to just quickly run through this. We'll not spend much time because we have a long way to go, right? Okay, I'm Deepak. Already you know me, you know my name at least. I've conducted more than 1500 hours. This is slightly dated. 1500 hours of training around new business technologies like Tableau, RStudio, Power BI, machine learning in past 7 years. I have managed projects of regarding automation of reporting system in my professional careers using Tableau, Click, and some other softwares. And yeah, and I am certified in big data analytics from Kelly's Business School, US, and I also hold certifications around CSM, Scaled Agile, and Prince 2 Agile. So that's a quick introduction about myself, and all of you know this. I'm going to quickly introduce Simplilearn, right? And then we'll proceed, right? Simplilearn was born with a mission to help professionals around the world acquire skills that are needed in today's digital economy. Very important. We all will agree that today we live in a digital economy. The task or the work that we do that has been made possible with digitization over the last decade, we could not even have thought of in the previous decade, right? So, and none of us can escape digitization, right? So, that was the big mission with which Simplilearn was formed almost 12 years back. Now, yeah, it is associated with 1,000 plus. It has more than 1,000 plus employees and associated with 2,000 plus industry grade trainers. And till now, it has conducted more than a million digital skill trainings across 150 countries. So that's the scale at which Simplilearn operates, right? Quick journey. As I said, it was started almost 12 years back. September 2009, Simplilearn was formed. Over the journey, they have in 2012 they completed a milestone wherein they had trained 20,000 professionals across 50 countries. Then another milestone was they made an acquisition in 2015, and they were after 2015 they have been awarded and they have been felicitated many times on LinkedIn and various other platforms as the leading online training company, right? So that's a quick introduction. These are some of the awards. I'm going to run through this. Categories of training in which Simplilearn is present: marketing and automation, full stack development, product and processes, and data and artificial intelligence. And our training R lies in the fourth flavor, data and artificial intelligence. Okay, so let me brief you about your journey and your experience. Your journey and your experience is going to be pretty much on mobile, on the go, means you can take this training from anywhere, right? And here I don't mean on mobile. At least or you cannot take this training on mobile because it's going to be hands-on, wherein you are going to be working on our software, right? You'll be learning, so you cannot take this training on mobile, but yeah, you can definitely take it from anywhere once you have a good internet connection. Okay, training anywhere, anytime, anywhere kind of experience, because you can also, you are expected to go through the pre-recorded content, right, before the session. So that will really help you build some ground around the topics we are going to cover. You'll be trained by global teaching assistants. There is going to be hands-on lab. I'll just discuss this. I would not prefer that you use lab. There are some limitations of the lab. Rather, what I'll prefer is that you should be using R and R, so R Studio, right, which I'll guide you how to download these, right? Okay, your training is going to happen on virtual classrooms like this. There will be assignments, mentorship, quizzes, and project work. So that is going to be your experience. That's going to be your journey, and very important, you are expected to be present in 80% of the live classroom training. Very important, right? Plus, you have to submit one project. Once you do both these things, you will be awarded a certification for this training. Is that clear? Any questions around this? Is this clear? Okay, great. So, some ground rules Saurabh did mention. We are going to start the training on time and we are going to end the training on time. All of you will be on mute only to avoid the background noise. But if you think you need to discuss something, you are most welcome to let me know and I can unmute you and we can discuss anything if you want, right? Discuss any related topic of course, right? Uh, but other than that, to ask regular doubts, right, or maybe chat with me, we'll use this chat box. We're going to have a break after 1.5 hours. We'll have a 15 minutes break. First 5 minutes, I'll open a poll. It will be a small poll, 5 minutes. Um, I mean, you will hardly take 5 seconds to complete it, but the poll will be open for 5 minutes. Please do participate in the poll to let us know how did you do in terms of pace and delivery. This poll will be focused primarily on the pace and delivery, how the pace is going on, right? And towards the end, you will be given the feedback form, which is very important for us. Please do participate in the feedback form and let us know your experience in terms of your training. Okay. And of course, I'm going to take you through the LMS, right? Apart from these ground rules, I will also share with you some health tips. It's going to be like, we all know, I mean, you know, it's going to be a 3 hours training. So I would want all of you to just keep a water bottle handy so that you can just keep on taking sips of water and keep your brain hydrated, as a hydrated brain is conducive for learning. Other than that, I would really want you to be sitting on a proper chair with back straight, neck straight, shoulders broadened in a proper posture so that you, I mean, you're not leaning somewhere or right. So that will really make your learning experience much better. Okay. So that's pretty much from my side. Social media, yeah, of course, if you like our experience, do let us know. Yeah, do let the world know, let your friends know, and do spread the good word around, right? So that's pretty much from my side. Thank you so much. Now, what I want you to do is, okay, what I'll do is I'm going to take you through this LMS. All of you have this LMS link? All of you have this LMS link? Yes? Okay. So, all of you can see there are 5 sections on the extreme left, right? Self-learning, right? First section, click on this self-learning and just scroll down. You'll have these links, course resource links. All of you have these links. All of you have these links. Please download datasets, download installation and configuration RStudio guide, which you will follow, and download R and RStudio after today's session. Next session, that is day after tomorrow, we are going to be working on RStudio. I am not going to, the guidelines are pretty much very clear, right? Even if you are a non-IT, you just have to follow the steps. So please do follow the steps and download R and RStudio. Let me quickly brief you. R is the base software, and RStudio is the integrated development environment. We call it IDE. RStudio is the IDE. You will be writing codes on RStudio, right? So R works, R and RStudio, they are just linked at the backend, and everything runs on R, but you will be writing everything on RStudio. So you have to download R and RStudio both. Okay, very important. Okay, then projects, you can just download these projects. Slides you can download, and lab guide in case you want to, you are really keen to work on lab, which I would not recommend, because even after, though the lab environment will be very similar to that of R, but once you save the file, I mean, once you work on a file in lab, you will not be able to save that file onto your system from the lab. That's one limitation, very important. So if you want to refer your material that you will be working on, so I would really want you to work on R Studio. Is that okay? Right? Any questions? Please download all these things from these links. Very important. Okay. Live classes, you will be as you are attending, you will be attending live classes, and in this section you will get the recording link of the previous class, right? So like this is not a class, this is, yeah. So like just like this, you will have a link, recording link, right? And you will have, sorry, just like this, you will have a link for each session, and you will have a recording link here. So maybe you'll, and that recording link will come after 24 hours of the session, when the session is complete. Very important. Please mind these. I mean, mark these things. Okay. After 24 hours of the session, recording link will be there, and you can download the recording of the class. Is that okay? Yes, Gaurav, you have to download both R and R Studio. Yes. Mehak, you're right. Past class link will be there, right? Practice lab, I've already told you. If you are really keen, you can explore this later on. Assessment, there are 7 projects you can see. Of these 7 projects, you just have to do and submit one project. Okay? Then there are some practice tests. See, all these 7 projects are marked gradable. Means you don't have to do all the 7, just have to do one. Okay. Then there are some practice tests for you to test the knowledge. You can go through these tests on your own. And last but not the least, certification. Once you have done with 80% of the class, right, and submitted one project, you will be, in a couple of days, you will unlock the certificate. Is that clear? Clear to all of you? Can we proceed further? Okay, great. Now I have introduced myself. Quickly, can I have all of your introduction one by one? And in your introduction, please do message your name. Please do message me your name, location. I'm writing it. Please don't write it right now. First let me put it: name, location, experience. Yes, Sahil, just hold on, hold on. Years of experience and any experience with R, if any. Any experience with R, if any, and just the way I have mentioned it in a single chat, mention all these 4 things with a comma. Don't split it, otherwise it will be very difficult for me to relate, because all of you will be typing it. Type everything in a single chat. Okay, Gaurav Andhra, 2.25 years of experience in NIT, 0 years, great. Next, can I have more introduction, please, quickly, so that we can get started now. Deshmukh, Sahu Deshmukh, Nagpur, 17 months experience, mechanical engineer. Okay. Next. You don't want to introduce yourself? I'm okay. Ranjit. Ranjit from Lucknow, 12 plus years of experience. Mehak. Mehak is from Raipur. Okay. Years, Raipur, years of experience and experience with art, 0. Okay, no. Okay, fine. Pradeep Kumar, fresher. Okay, Mithun, 3 years of experience. No prior experience in art. Idris, I hope I'm pronouncing your name correctly. Idris, UK, studying my master's in data science and 6 months years with R. Okay, great. Idris has experience with R. That's good. Then, next we have Pallavi. Mm, yeah, Pallavi. Pallavi is from Indore, 8 months of experience in sales, no experience in R. Alok Bhardwaj, 19 years of experience in Ghaziabad, MBA or MBA and MCA. Okay, we have Stanish. I hope that's I'm pronouncing your name correctly. Stanish is from Tamil Nadu. We have Prasad from Bangalore, 10 years of experience. Then we have Kanupriya from Lucknow. We have Sahil from Nagpur. We have Vinod from Delhi. And we have Tasneem from Noida. Thank you, all of you, for your wonderful introduction. Then we have Karthik. Karthik. Okay. But your name says Vivek. I'm going to call you Vivek only because I will remember Vivek only, which is there on the screen. Uh, Fine, Karthik, I'll try to remember your name. Karthik is from Ahmedabad, 7 years of experience, sales coordinator. Coordinator. Okay, great. Thank you so much, everyone, for your wonderful introduction. So let's now get started with introduction on R, and so I'm going to start. Okay, let me do this. I'll slides. Let me just download these slides. Though we will introduction to business analytics, introduction to R programming. Okay, fine. So these are the slides I also have. Perfect. I just wanted to check whether they are not updated. Perfect. So let's start introduction to business analytics. Okay, everyone can see my screen? Okay, so let's start with a very interesting case and very interesting incident that happened almost 30 years back, right? Almost 30 years back, this incident happened, and of course, 30 years back, the technology was not that robust, digitization was not there, right? But still, business decisions were taken, right? And this decision that Coke took was a disaster, right? And let's quickly learn about this, right? Coca-Cola announced a change in its nearly century-old secret formula 30 years ago, right? So almost 30 years ago, I think it was in 85 or something like this, or 83, I don't remember. Coca-Cola announced a change, and all of you, I mean, those who drink Coke, do you have you, I mean, seen that they write the original formula, something like that, original Coke or something like that, they write on their uh, original taste, something like that. They do write. I don't know the exact words. Yes, those who drink Coke, those who are patrons, those who are fans, they must be knowing, right? It is because of this incident they started writing, right? So they changed the century old secret formula and they tried to bring in a new taste, and that taste was the new Coke would have a smoother, sweeter taste similar to Diet Coke of today, right? But sweetened with corn syrup. Yeah, original taste, something like that. It's written, right? Okay. So what they did was they tried to change the taste, right? Market researchers and pollsters were sure it's going to be a hit. They did some market research, they did polls, and they came up and they said it's going to be a big hit. But actually, what happened? The poll after the launch showed that only 13% of the soda drinkers liked the new Coke. The experiment was not accepted by the customers, right? And it was a huge disaster. Coke drinkers launched grassroots campaigns across the country, of course, US. right, to force Coca-Cola to bring back the original Coke, which compelled the company to work on it and bring it back. And since then, they have never tried to experiment it, right? And they had spent lot of money on this, lot of resources, lot of energy went into trying to change this. But what happened is in front of you, and you can go through this, the details of this maybe later on through Google. Some of the Coke drinkers or the some of the, you can say, fans or patrons, they really went on to extreme limits. Some of them really stored crates and crates of the original Coke that was still there in the market. And some other, I mean, they launched grassroots campaigns is something that was very still something very mild. Some extreme steps they had taken, which is not covered here, right? You can go through the details later on, right? But where did the company go wrong? It made a wrong business decision, right? And Donald King, the president of Coca-Cola at that time, stated the simple fact is that all the time, money, and skills poured into the consumer research on the new Coca-Cola could not measure or reveal the depth and abiding emotional attachment of the original Coca-Cola felt by so many people, right? So probably what would have happened was they, the matrix or the data they collected, the surveys they created, they were just focused on pushing their product. They never tried to understand the emotional attachment. So they were chasing the wrong bus. They were chasing some wrong matrix, and because of that, this decision they tried to take, it was a huge disaster, right? The right business decision help the, what is the right business decision now, right? Right business decision is a decision that helps business achieve higher revenue, reduce expenses, and or meet customer expectations, right? If either of these things are met, right, it is a right business decision. Of course, all of these are going to impact the profitability, and in the long run, it's going to increase the value of the business, right? It involves a series of methods and techniques to measure performance. As I said, they were chasing wrong metrics or wrong indicators, right? So it involves a series of methods and techniques to measure performance and improve them. And this is called business analytics. The field that helps business measure the business performance, track them, improve them, is called business analytics. Is that clear? What is business analytics, everyone? Okay. Business analytics is a scientific process that transforms data into insights. See, you collect data, but from that data, you generate insights, right? For example, you collected sales data for last 12 months, but what insight you could draw from it was that the sales dipped by 30%. That's an insight. Data you collect, and from the data you generate insights. Is that clear? Right? It's a scientific process that transforms data into insights that is used for fact-based and data-driven decision making. Okay. Another very important thing. See, decade back or even prior to that, many business decisions were taken by experienced professionals, by and with sometimes with gut feeling also, right? And that gut feeling becomes stronger and stronger when you become more seasoned or more experienced professional. That used to become, but today every business decision is data driven. Data driven is a very important term. Every business decision today is taken based on data. Not very few decisions would be taken based on experience or gut. Most of the business decisions are now taken based on data. That is why data has become so important, right? And with digitization, with so much digitization around us, not only humongous amount of data is being produced all around us. When I say all around us, of course, all around business also, but the storage cost of that digitized data has become so cheap that every business can afford to store huge amount of data which from which it can track not only its historical performance but it can use that data to take uh, good, not I would not say good, but to take smart business decisions. Okay, I'll come to you, Sahu. Just give me a minute. Right? It uses tools such as reports, graphs, optimization, data mining, and simulation to take smart business decisions. Okay, Sahu says, is it correct? Insight shows trend with the help of past data. Insight not only shows trend. Insight means something you can derive out of data, raw data. Okay, it could be a trend, it could be any hidden message, it could be any uh, some, you can say, some finding, right? Progress, right? Or maybe a decline also, right? So anything that you are able to derive from raw data is called insight. Okay, so features of business analytics. Quickly, I'm going to run through this theory because I just want to quickly pass through this so that we can start with the fundamentals of statistics, right? Business analytics offer rather helps in decision support system, helps as a decision support system. Means business analytics solutions are primarily used as decision support system or as their components. Means solutions help executives, salespeople, and other professionals across the organization to take business decisions. Okay, first is help in taking business decisions, which we have already discussed. Business continuity support. It also aids in functioning. It also aids in functions such as hiring, reducing attrition, improving retention, performing staff deployment, and deciding strategy. So, right from tactical decisions to strategic decisions are based on analytics today. Okay, so it acts as business continuity support. Third is various methodologies. Methodologies include concepts from applied probability, applied mathematics, applied statistics, and computer science. Data produced helps you gain meaningful insights into better business planning and business performance. Is that clear? So these are the three big areas wherein by which business analytics help business. Is that clear? Any questions on this? Okay. Another thing is our training is not going to be a one-way download, right? I've already told you, you are free to participate, you are free to contribute, you are free to add comments. Even if you want me to unmute you, I can do that. At the same time, I would expect and I would really request all of you to please be responsive whenever I'm asking, because see, I can just run through every slide without even asking, but that is not my way of doing, right? When I'm asking, is it okay? At least some of you take responsibility to respond, because I know all of you will not respond at the same time. Some of you would be maybe absorbing, some of you would be writing some codes when we'll be doing our, right? But some of you can take responsibility and reply to my questions. Is that okay? Do you agree with me? And that will help all of us save time, right? Otherwise, what happens is I keep on asking, and if there is no response, I don't proceed. I push that please at least some of you respond, right? And that seconds get piled up towards the end. And I don't want that we are really leaving any stone unturned, any topic we are leaving, and any doubt I'm not clearing. Is that okay? Thank you so much. And that's the only support I would really expect from all of you. Okay? Thank you. Okay, great. So now we'll cover this later. Types of business analytics, descriptive, predictive, prescriptive. I'll cover this later. Okay, fine. Applications, I want you to go through these applications are there in the first video also, that is the self-recorded. You can go through this, but I am going to cover these types of business analytics, right? So let me quickly, yeah, these are all applications, right, of business analytics, which you can go through and just listen to the recordings. Okay. Okay. Data science. I think this will also, I'll cover data science in the separate PPT. Perfect. So let's start with data science. And what is, I'm going to share all these PPTs, right? So you don't have to write anything. Okay. So what is data science? When we say business analytics, right, we are in the field of data science only, right? And what is data science? If you can just look at this picture, right? Look at this picture closely, right? I'll just give a couple of seconds. Look at this closely. Data science, can you see it's a confluence, it's a intersection of three major fields. That is why it is called a multidisciplinary discipline. Multidisciplinary subject, because it involves the knowledge of business domain. Business domain, when I say, all of you would be belonging to different industries, right? So when you start applying business analytics or data science in your industry, you are expected to have a knowledge about your industry at least, right? The business domain you belong to. Okay. So it involves the knowledge of business domain, maths and statistics, which we are going to start immediately after this presentation. That is fundamentals of statistics. You are expected to have good understanding on the fundamentals of maths and statistics, and information and technology, IT. Of course, when we are starting to learn, when we learn R, you will definitely be learning that software, right? And you will be uh, learning IT only, right? Is that clear? So it's a multidisciplinary discipline. Data science concepts and processes are mostly derived from data engineering, statistics, programming, social engineering, data warehousing, machine learning, and natural language processing. The key techniques in use are data mining, big data analytics, data extraction, and data retrieval. All these are terms that are related to data science. Okay, so let me take you a step back and let's understand what happened that data science has evolved. Why did data science evolve? Right? So there is a decade old story. I mean, decade old, uh, we can say this transition has been a decade. It took a decade to actually uh, build, right? So I'm going to just cover that decade in just a couple of passages or couple of sentences, just to sensitize you what happened that led to the evolvement, or that led to the subject called data science. Okay, all of you know that digitization, you have been experiencing digitization for almost 2 decades or more than that, right? In fact, more than that, right? I would say 40 years or more than 40 years when the first computers, first PCs were invented, right? Digitization started back then, right? So with digitization, more and more data started producing because everything started to be recorded in a digital format, right? Everything. And with internet invented in early 2000s or late 90s, the world became more connected. The world became, everything became digitized. Everything started to become digitized, right? And more and more data was produced and recorded in every field, right? Produced and not just produced, recorded also. This led to the increased need for storage. Now, in the last 10 years or so, if you look back, maybe you can just go to Google and check what was the cost of storing 1 GB of data almost 10 to 15 years back, right? And you will be astonished, and if you don't know that the cost of storing 1 GB of data was somewhere around $100. I'm talking 15 years back. Okay. And today, what is the cost of storing 1 GB data? On the cloud, it's free. And there are places wherein you can even store 1 terabyte of data for free, right? There are places wherein you can store terabytes, not just GBs, right? So this digitization has led to the increased need for storage of data, and hence frameworks to solve the data storage problems started erupting, right? So people started, the businesses, they started to work on this problem, that how do we reduce the storage cost? Otherwise, storage was so expensive that producing so much of data was not uh, viable. It was not viable to store that much of data that was produced. And if you remember, even going back to your emails, if you remember the early emails, they were just a couple of GBs. The email boxes were just sometimes even MBs, right? And you would probably keep on deleting them, right? The same thing was happening. The next focus was the need to dig and process the big data. Now, when this problem was of storage was solved by various technologies coming up like cloud computing, then all of you would remember pen drives. Do you carry pen drives now? Do you carry those hard drives now? Hard disks? Seldomly, very seldomly you would be carrying that now, right? Gone are those days. And I'm sure you would remember the days of CDs and floppy disks, right? Pen drives are still, I know you still get pen drives on Amazon, but very soon they will also be vanished. You'll see they'll also be history very soon, right? Because everything is getting into cloud, and with cloud the cost of storing has cloud computing has solved that storage problem, right? Every business today, they are storing their data on private clouds, right? And these private clouds are hired cloud spaces by cloud vendors. Okay. So once this data storage problem was solved, next focus was the need to dig and process the big data. Right now, storage problem was solved, so businesses were able to store huge amount of data. Okay, I still remember when I did my big data course in 2014-15, right? Our professor, he was from US, and he used to say that every business is storing data because the storage problem was solved then, but they don't know what to do with that data. So we were at this stage. Next focus was to dig and process the big data. They were storing data. They were holding a lot of data because they knew this revolution is taking place, but still they did not know with confidence what to do with that data, right? And generated insights to optimize business performance. Now, this was the next step. Now, they would work on big data and generate insights to optimize business performances, and that is what has happened in last 6 to 8 years, right? Improve to optimize business processes, improve business processes, optimize business performance, improve business processes, forecast and build models that predict accurately. This is the field where data science has an important role to play. Data science is a field of big data geared towards providing meaningful insights based on large amounts of complex data. Data science or data driven science combines different fields of work in statistics and computation in order to interpret data for the purpose of decision making. Is this story clear? Is this making sense to all of you? The last 15 years, what has happened that has led to this world of big data or this data science open up in a big way to all of you, right? Okay, great. Thanks for the confirmation. Really appreciate that. Okay, great. So quickly, I'm going to take you through the data life cycle, right? Data science life cycle. We will move quickly here, right? The data science life cycle starts by understanding the business problem. So business understanding means understanding the business problem by asking relevant and appropriate questions. Once the business problem is frozen or is clear, right? Then you start collecting data to understand that problem, to understand that problem and to come up with solutions to tackle to that problem. Okay. Once data is collected, when you collect data, it is not fit to be analyzed. Remember this. When you collect data, data comes from different sources. Okay, all of you agree to this? That today business does not generate data from a single or does not work on data from a single source. Do you agree? Today data come from various sources for not just for business, for even for an individual also, right? We rely on different sources of data, right? So now when you rely on different sources, do you think the format of the data will be consistent? Do you think the headers will be consistent? Do you think the structure of the data will be consistent? No, right? And so, and it is not. And when you pull the data from databases, also they have their own structures in which the data is stored, which is not fit for analysis. So data preparation becomes very important. Once you have got the data, preparing data, and you would not believe then that in this entire life cycle, data preparation in terms of timing occupies 50 to 60% of your time. You spend 50 to 60% of the time preparing the data. Okay, that is why data preparation is so important, because if data is not prepared correctly, the models that you're going to create on that data would definitely be haywire. They would definitely be not the ones that you would want. So data preparation is very important. Now, what is data preparation? It involves raising the data quality to the level required by the analysis techniques that you have selected, like tools like Tableau, R, Python, Power BI, right? All these would want the data in a specific that they should be clean. And in fact, tools like Tableau Prep, tools like Power BI, they are robust enough that they help you prepare this data. You bring in the raw data and they help you prepare the data, they help you clean the data and make it fit to be used in data visualization or the models. Okay. So it involves data preparation, involves selecting clean subset of data. First, you will clean the data. You will plug in the NAs. You will remove the NAs. You will use some dummy variables. You will create some new variables if needed for the analysis. You will insert the suitable defaults, estimate the missing values. After you have cleaned the data, and see, think, you would be saying, okay, only 3 or 4 steps are required. Think in terms of big data, a million rows across 100 variables. That is the extent of data when you're working with big data. On that data, which is, let's say, a million, which has a million rows and across 100 variables, when you start doing these steps, it's going to take a lot of time, because these are steps that you have to do it manually, right? Not manually, of course, not everything is to be done manually, but like creating new variables, but it will involve your expertise here. Okay. Now, once you prepared the data, you start doing another very important step is called EDA, exploratory data analysis. Now, what is exploratory data analysis? Once you have cleaned the data, once you have prepared the data, right, you will again not immediately put the data into the model, into the tools to create models or visualization. Why? Because you would want to understand the data. Okay, suppose I give you a clean data, right? I have cleaned the data, let's say data of um, iPhone users in India, right? Some data, how many hours they are spending, what time they are spending, what apps they are using, which iPhone they are using. Suppose I give you this data and I ask you, okay, use R and give me insights. Do you think you will be able to give insights? No, because you did not understand the data. You did not spend time with the data. Okay, that is called EDA. Try to understand what are the underlying patterns, right? Try to understand, and EDA involves you to create some basic visualizations. EDA will involve you to create summary statistics. EDA will involve help. You will be probably uh, calculating basic statistic, uh, basic statistic matrix, right? So that you understand what is this data about, what are the important metrics, okay, how is the sales trend going on, how is the profit trend going on over the period, right? So this is called exploratory data analysis. Is this clear? What is EDA? It is called EDA. The main role of EDA is to open-mindedly explore with visualization to gain new and unsuspected insights into the data. Right? This is done before you start putting the data and before you start creating models. Is that clear? EDA, exploratory data analysis. Is this clear? Okay, thanks for the response. Right? So once you understand the data, once you uh, get comfortable with the data, once you are able to get a hang of the data, then you work with data models. Then you start the modeling technique, select the modeling technique. More often than not, a single model may not be able to generate satisfactory result, and then you generate multiple models. You create multiple models to uh, forecast, to cluster, to uh, take business decisions. Okay. In such a case, an ensemble of models is used. Ensemble means collection of models. Many a times you will see when you start, it is not that a single model is enough. You will work with regression, decision tree, random forest, PCA, factor analysis, SVM, Lot of models are there, and there is no fix or no best model, right? Many, you will be using a collection of collectively you will be using multiple models to to come up with a forecast or to come up with a final solution for the business problem. Is that okay? After assessing the model, iterate model building and assessment is done until you're confident that you have found the best model, right? Then model evaluation. Once you have build some models, then you evaluate those models, right? And in the end, you deploy those models. How do you evaluate? We will do. So all these steps from preparation till model evaluation, not deployment. From preparation to model deployment, we are going to cover. Of course, we will not be doing data collection. Business problems, of course, partially we are going to see what are the different business problems you can tackle with data analytics, right? So these are the things we are going to be covering in our curriculum. Is that okay? Any questions? Let me know, else we'll proceed further. No question? Perfect. Now, coming on to these terms: descriptive, predictive, prescriptive data science, right? So, what is descriptive data science or descriptive analytics? It's a field, or it's a, you can say it's a field of analytics that help you answer what is the current business situation. Okay, what happened? It helps you answer what happened. So, what is the past and what is the current business situation? That is that part of analytics that help you answer these questions are called descriptive analytics. It is primarily historical data we are analyzing here. Is that okay? We are analyzing a historical situation at max current situation, right? Clear? Descriptive. Then comes diagnostic. Now, based on historical data, we try to diagnose the problem. Why it is happening to my business? For example, let's again take an example. Last 12 months data I collected, and I found out that my sales have dipped 30%. So description or descriptive analytics will tell me sales have dipped 30% in last 1 year. Diagnostic analytics will, I will start digging the reason for it. Why did this sale decline? Why did it happen to my business? Analyze and drill down to the root cause here. We will in diagnostic, as the word itself say diagnose, we try to diagnose the root cause. Ability to isolate all confounding information. So we try to diagnose. We just drill down each and every aspect. We just drill down each and every part or each and every metric to the root so as to understand what led to this decline of my profit or of sales by 30%, right? Is that clear? Okay, next, predictive analytics. Now, I have got historical data till today, means till present, right? Now, I have done diagnose, and I got to find out, okay, my sales declined because there were a couple of competitors that entered the market and they were doing really uh, very heavy marketing, right? I'm just cooking a story here, right? So I will take corrective action. I will also take some action here. Once I have found the root cause, I will also increase my marketing expenses, right? I will also increase my marketing expenses significantly so that I can so that I can increase my sales, so that I can reverse my sales trend in future, right? So now when I increase my marketing expense for, let's say, next year, right? So I'm going to, based on the increased marketing trend and the changed market conditions, because my competitors are also very competitive, and they are heavily uh, spending on marketing. So the market dynamics have changed. It has become far more competitive, far more fierce than it was in the last couple of years, right? Based on that, I am going to predict what is going to be my sales in next 5 years or next 3 years. What is likely to happen in future? That is called predictive analytics. Is that clear? Business strategies that fairly remain consistent over time, historical patterns used to predict specific outcome using advanced tools, technologies, and algorithm. Decisions are automated using. I mean, these are just some of the related information, but the big message here is predictive means what is likely to happen in future. That is called predictive analytics. Is this clear? Lastly, we have prescriptive analytics. Now, what is prescriptive analytics? We What do I need to do now? What do I need to do in future? That is called prescriptive analytics. So based on current situation scenarios, I would give some, as a data scientist or as a business analytics professional, I am going to give some suggestions, prescriptions to the business. Keep your marketing expenses, increase your marketing expenses, let's say every year by 20%, right? I'm just giving some recommendations. So that becomes prescriptive analytics. Based on the data, based on the trends that are shown by the data, I prescribe some suggestions or recommended actions and strategies based on testing the strategy outcomes, applying advanced analytic techniques like machine learning and business rules and algorithms to come up with these prescriptions. Is that clear? What is descriptive, predictive, prescriptive, and diagnostic? Any confusion in these four terms, let me know, else we will proceed. So I believe this is clear to all of you, right? Prescriptive is based on diagnostic. Prescriptive, yeah, of course. Diagnostic, you are historically diagnosing, right? Not just diagnostic, but also predictive. You are predicting, okay, we are going to increase our sales, but then what suggestions are you giving to keep those sales at that level, right? So based on all these previous, you prescribe. Okay, is that clear, Bindu? Okay. Now there are some related terms, AI, machine learning, deep learning, which is not part of our curriculum, but I have still given because they are very interesting fields related to data science. So, but you can go through these, right? Okay. So I'll share this and you can go through these. Now we are going to move into the most important part, that is fundamentals of statistics, right? How many of you have done statistics sometime back in your high school or sometime back in your lives? Type S if you have done statistics. Type S. S for statistics. If you have never done, type NS. Not done. Type NS. If you have not done. Okay, there are people those who have not done. One of them is there. Okay, Ranjit is also there. Okay, Sat. Uh, can I know your name, please? Sakti. Sakti, is it? Okay, Sakti, right? Okay. So couple of you have not done. Sakti, Vivek, and Ranjit. Have you never calculated mean median mode? Three of you? Have you never calculated mean median mode? Okay, Ranjit says, so then you have done something about statistics, basics. Okay. What about Sakti and Ranjit? Oh, Ranjit responded already. In 12th, yeah, so that's what I'm saying. So that's what I'm saying. So that's okay. That's what I'm saying. I was, I mean, really taken aback that you have not even calculated mean median mode. That is statistics. Okay, basics. Okay, so let's get started with statistics. What is statistics? It's the field of mathematics, right? One, it is a field of mathematics, or we also say that it's a field of science. So it's a, you can say, a overlapping of science and mathematics, you can say, right? Science concerned with, now it is concerned with specifically developing and studying methods for collecting, analyzing, interpreting and presenting of empirical data. Okay, so it is a field where which deals with collection, analysis, interpreting and presenting of data. Is that clear? All these four things are included in statistics. It is also called the science of data and information. Whenever you are dealing with data, or whenever you are dealing with any information, right? It's called, it has to do something with statistics. Okay, form of mathematical analysis that uses quantified models, representations and synopsis for a given set of experimental data or real life studies. Basically, the big words are put in bold. Mathematical analysis that uses quantified models, representations and synopsis. Studies methodologies to gather, review, analyze and draw conclusions from data. Again, the words are very important. You don't have to by heart it, but understand the meaning of each and every word. Gather, review, analyze and draw conclusions from the data. There are two branches of statistics which, which we are going to do: descriptive statistics and inferential statistics. Anyone who has done inferential statistics earlier? Okay, let me right put the right word. Anyone of you who has done hypothesis earlier, type H. If you have not done hypothesis anytime, type NH. I want to see how many of you have done hypothesis earlier. Hypothesis is inferential statistics. Okay, so I can see more of NH. Okay, great, fine. So inferential statistics is the fundamental, or is the ground, is the base on which predictive models, or you can say it's the base for data science or business analytics. Okay, of course both of them, descriptive and inferential, are the base for this, right? Okay, this is just additional information. The word statistics is derived from Italian word stato, which means state, and statista refers to a person involved in the affairs of that state. Therefore, statistics originally means the collection of facts useful for the statista. Okay, perfect. So let's see what is descriptive and inferential statistics. Descriptive statistics is what all of you would have done, right? Like, descriptive statistics include measures of central tendency. All of you have done mean median mode. I can bet you would have done mean median mode any times in your life, right? Okay, that's called measures of central tendency. It's called measures of central tendencies. We'll see why it is called measures of central tendency. Then another very important part of descriptive statistics is measures of dispersion. Can you tell me what is the meaning of dispersion? This spread, right? Spread or differences, right? Different distribution, right? All this is measures. So the measures of dispersions include, just hold on for a minute, just hold on for a minute. Hello, yeah. So spread of data, measures that help us understand how much is the spread of data, right? We will see these in detail. Herein we are going to study and understand what is variance, what is standard deviation, what is range, what is interquartile range, count, mean, minimum, maximum. We are going to learn all these. Third part of descriptive statistics is understanding the shapes of the distribution, understanding the shapes of the data, right? Herein we are going to learn the concept of skewness and kurtosis. If anyone can recall, those who have done skewness and kurtosis, type SK. And those who have never heard of skewness and kurtosis earlier, type NSK. I'm not saying that you should remember it, but if you can recall these names, type SK. Those who can't recall at all or don't know these words, type NSK. So almost 50-50%. Okay, great. Those who have responded, it's okay. NSK is now holding more weight. Perfect. Okay, so and last field about descriptive statistics is charts and graph, histogram, bar chart, line chart, pie chart, scatter, heat map, box plot. I'm sure all of you would have heard about bar chart, line chart, pie chart, histograms, at least these four. Yes, that is also part of descriptive statistics. Okay, so this is all we are going to learn in descriptive statistics. Then comes the second field of statistics, that is called inferential statistics. Okay, now inferential statistics use sample statistic to make prediction about the population. Let me simplify this. Inferential statistics use samples from the population. Can you see this population? Now here notice we are going. I am using two words, two statistics words, population and sample. They have a separate. They have a very different meaning, different from the population that you know as a layman. Okay, so we are going to understand what is population and what is sample, right? But what is population is basically, okay, let me just in brief tell you, population means the whole universe that we are trying to study or that we are trying to analyze. Okay, so if this is the population, in inferential statistics, we use samples, we pick samples from the population. First step is take samples using some sampling techniques. Now we analyze these samples. This is we are analyzing them, and then we draw inferences, estimates, and conclusions about the population. Okay, these are the three steps that are there in inferential statistics. Very different from descriptive, right? So now, since I have introduced you to two words, population and sample, let's understand what do you mean by population and sample first, right? So that you are very clear on population and sample, right? A population is a collection of people, item, or events about which you want to make inferences. Let's take an example here, right? I want to know how much time an iPhone user spend on his phone during the day. Okay? All of you got my question? What I want to analyze and what I want to come up with, right? So tell me, no, Vivek did not get it. Vivek, I'll repeat for you. I want to know how much time an iPhone user spend on his phone during the day. Is that clear, Vivek? Okay. So, uh, what is the area of my study, or what are the people I'm going to study? Will I take, will I study or will I analyze people those who have Android phones? Do you think I will analyze people those who use Android phones? No, right? I'm going to analyze people those who use iPhones. So that becomes my population. Okay. Now let me further refine it. I want to study the the phone usage habits for people in India. So what will be the population? Tell me what will be the population here. Will it be people of USA? Phone users in India. Excellent. Tasneem, right? Amatullah, right? I hope I'm pronouncing your name correctly. Amatullah. That's your first name? Okay, perfect. Right? So excellent. Phone users of India. Even people those who don't have phone in India, that is not my population. Not Indian people, Pradeep. Are you getting it? I am saying I want to understand, I want to study the phone usage habits of people in India. Of course, they are going to be people those who it's going to include only people those who use phone. Okay? Is that okay? So that becomes my population. It's a collection of people, item or events about which you want to make inferences. Is that clear? Everyone? Okay. Now, can you see, even in our examples, the population is so huge, isn't it? In the first case, iPhone users, do you even know how many iPhone users are there in the world? It would be in millions, right? Do you think for a business or for a person who really wants to make some inferences, it is convenient or possible to go to each and every iPhone user and collect data? Do you think that is practical? It is feasible? Not possible, right? That is why we deal with samples, right? Not always convenient or possible to examine each and every member of the entire population. Hence, we have to deal with samples. Okay. Now, population is has some characteristics like population mean, population standard deviation, right? These are called population parameters. Is that clear? They are called population parameters, and these are population mean. Statistically, it is represented by mu, which is a standard statistical notation. Okay, mu means population mean in inferential statistics. Sigma means population standard deviation in inferential statistics. Is that clear? So these are called population parameters. Next, sample. Sample is a subset of people, item or events collected from a larger population, right? That you are going to analyze to make inferences. Is that clear? You collect samples from the population, then you analyze those samples, and then you make inferences about the population. You try to infer about the population. Okay? Can we have access to the? Of course, I said Jack. Okay, I think Jack, you did not. You joined late, maybe, right? You will be getting all these PPTs from me. Okay? So do not. You don't have to take any notes. Just concentrate on understanding the concept. Is that clear? Can I proceed? After I complete sample, we'll take a 15-minute break. Okay? Okay. To represent the population well, a sample should be randomly collected and adequately large. It should not be biased. It should be randomly collected. Is that making sense? Otherwise, how will it represent the entire population? Isn't it? If it become biased, right, it would not represent the entire population, and it should be adequately large as well, so that it is able to touch upon most of the features of population, isn't it? Statistic, just like we have parameters for population, for samples you have statistics. So statistic is the value that describe the characteristics of the sample. So these are called sample statistics. Sample mean represented by small x and bar. Okay, and sample standard deviation is small s. These are called sample statistics. Is that clear? Is this clear? What is population? What is sample? Any question till now? Let me know. Else, what we are going to do is now we will take a break. I'm opening the poll. Hopefully, you are enjoying the session and you're learning something interesting and new. I'm opening the poll. Please do participate in the poll. Let us know how did you do in terms of pace and delivery. And the poll is open now. It will remain open for 5 minutes, and we are going to take a 16 minutes break. Okay. I am putting up a timer on the screen. Please do come back as per the timer. Thank you so much, and I'll see you on the other side of the break shortly. Okay, welcome back everyone. Thank you so much for participating in the poll. Please let me know if you are able to hear me out. You're able to hear me? Yes? Okay, great. Thank you so much. So we will continue with descriptive statistics now. Okay? Okay. So okay. So we are done sample and population, right? Now descriptive and inferential is also clear, right? Now this is just a tabular format in which I have just compared descriptive and inferential, right? You can go through this. Now, as I said that statistics deals with data, right? Okay, so statistics deal with data. So, do you think every type of data, the data is of same type? No, right? Data can be of different types, right? For example, we broadly classify data into two categories, that is qualitative and quantitative. Now, what is qualitative? A variable that describes the population or sample element, right, is called qualitative. It is also known as categorical variable, okay, and it is or attribute variable, okay. For example, color of the product, color of iPhone. Suppose I am collecting this data, color of iPhone. Do you think this is a quantitative data? It deals with numbers, or it is a qualitative data? It describes the It describes the uh, population or sample element. What is it? Qualitative or quantitative? Quickly. Qualitative, right? Now, similarly, we also have like this true false. Some data which is in the format of yes, no, or true false, right? It is called Boolean data. Boolean data is the data that is in the format of true, false, yes, no, 1, 0, okay, on, off. That is called Boolean data. So something like switch variables, okay. Then customer type, example, male, female kids. Order data, some order, some data that can be ordered, let's say grades, right, or height, or area, right? Not area, but grades or height or any numbers, right? So they can be ordered, put in some order, right? So then location of delivery of order, right? Location of delivery for, let's say, Zomato, okay? City, country, code, pin code, region, all these are categorical variable or qualitative variables, okay. Now a very important feature about qualitative, see, many a times there are some variables, they may look like quantitative but actually they are qualitative. I'm going to discuss those, but one, you can say, it's like a thumb rule, or you can say just a uh, yeah, thumb rule, you can say, right? To identify or to differentiate qualitative from quantitative, just remember this sentence. Arithmetic operators such as addition, averaging do not apply to qualitative variables. And for quantitative, arithmetic operators apply to these variables. Is that clear? This, with this simple sentence, you can differentiate between any qualitative and quantitative variable. There are a lot of variables that get confusing. I'm going to discuss these, but remember this, okay? You will never get confused, okay? So quantitative are variables that can be quantified. Numeric variables, for example, height, weight, sales, profit, count of footfall in a mall, number of beds in hospital, number of flights took off in a day, all these can be counted. Now, let me give you some variables. You have to tell me whether they are qualitative or quantitative. Floor numbers in a floor number. Remember, floor number in a in building. Can you add two floors? It's qualitative, right? 10th floor in one building, 15th floor in another building. Can you add them? Can you apply mathematical operator? No. Okay. Okay. Another phone number of the employees. Purely numeric data. What is it? Quantitative or qualitative? Qualitative, right? So that one sentence, if you will remember, apply arithmetic operators. Can you apply arithmetic operators on phone numbers? No. Can you apply, okay, ranks in the class? Is it qualitative or quantitative? Ranks, again qualitative. I deliberately took all the three as qualitative so that you can easily differentiate and apply this sentence, this arithmetic. Yeah, rank is ordered. You're right, Alok. Okay, clear difference between qualitative and quantitative? Okay, now let's dig one level deeper. Qualitative, I already told you they are called categorical or attribute, and quantitative are called numeric, right? Further, qualitative or categorical variables can be of two types, nominal and ordinal, and numeric can be of two types, continuous and discrete. Let's understand these. First, nominal variables. Nominal variables have two or more categories and no natural order to these categories. Is that clear? They are named. They are named. Nominal comes from the Latin word pertaining to names. Okay. So nominal means names. For example, names of people, cities, then names of buildings. Uh, okay. All these are categorical nominal variables. Gender, right? Male, female, child, names of cars. Okay. Then comes second type of qualitative variable or categorical variable, which is called ordinal variables. Ordinal variables have at least three categories, and the categories have a natural order. Categories are ranked, but the differences between ranks may not be equal. Is that clear? Example of ordered. Grading, percentile, uh, ranks, right? Then um, what else can be? Yeah, good, better, best. Yeah, that those are ranks only, right? Then floor. I just spoke, right? Floor. Yeah, anything that you can put on a scale, as Amatullah said, right? Scale, pain scale, right? Or very good, pain scale can also it is ranked. Okay, then maybe other rank, other things that you can really rank. Um, Quality scores, right? Customer feedback, correct, right? All these are ordinal. There is a Likert scale on which you can create these ordinal variables, right? So that's out of question and out of our curriculum. I just remembered the name, so I spoke, right? Okay, right? Clear what are ordinal? Now, continuous numeric variables. A numeric variable that can take values on a continuous scale like age, weight, sales, profit, right? All these are continuous numeric variables. Decimals, yeah, having decimals, correct. They can have decimals. Now, discrete numeric variables like number of employees, right? Count of cars. Can you have 2.5 cars? Not possible. They are discrete numeric variables. Is that clear? Coming to the scales of measurement. Now, since we have spoken about the four types of data, on what scale are they measured? Nominal, categorical variables where no order is or direction is there, or you can say nominal variables only, right? They are measured on a scale which is called nominal scale. Okay, then you add order to categorical, right? Like ranks, orders, scale, you measure them on ordinal scale. Okay, further, when two variables, when the difference between the values of two variables can be measured, but they do not have any true zero. I'll explain this to true zero. What is true zero, right? They are called interval scale, and wherein the difference can be measured and actually there is a true zero value. They are called ratio scale. So let me give example. Nominal is clear to all of you. Ordinal is also clear to all of you, right? Nominal and ordinal are clear. Yeah, temperature. Yes, Amatullah, you're right. I'm coming to that, right? Interval scale. Let's understand. I said scales in which distances between consecutive numbers or two values have a meaning and data are always numerical. But the important thing about interval scale is there is no pre-decided starting point or a true zero value. What does this mean? For a temperature, do you think there is a starting point for a temperature? Do you think there is any zero, just like zero sales? Can there be negative sales? Can there be negative sales? No, right? So it has a predefined zero, and then from there it starts building value. Okay, but temperature, you will say we have zero temperature, but actually it is not zero. It does not mean that there is no temperature. Zero temperature is the value we have given to that particular temperature. Okay, we we can't say there is no temperature. Are you getting my point? So it's a interval scale. We that is called interval scale, IQ scale. We will give scale a zero value, but actually you can't say that this guy does not have any IQ. Are you getting this point? Time. Did you get it? Time. Okay. Next, ratio scale. The only difference is they will have a true zero value. There is a true zero means There is an absence of property. For example, sales, zero sales means no sales. Okay, zero population in a city means no person in that particular area. Is that okay? Height, zero height means no height. Zero weight means no weight. Is that clear? Difference between ratio and interval is clear to all of you? Okay, so this is just a table comparing all these four. You can go through this. Okay. Sample population we have done. Now coming to measures of central tendency. We are going to do measures of central tendency and measures of dispersion today. Right? I think we should be able to do it. Then box plot we'll try to finish. Otherwise, we'll do box plot in the next session. And skewness and all these. Okay. Okay. Measures of central tendency. So what are the measures of central tendency? There are three measures of central tendency. What are these? Mean, median, and mode. Very good. Okay, I'll share this Excel as well. So you don't need to write anything unless and until I tell you to do. Then only write. But I will not tell you. In fact, we are going to write only on our studio next class. Okay, perfect. So let's start with mean, median, and mode. Okay, these are three data sets. Can you see? Quickly take a look at these data sets. This is data set 1, 12 values or 12 observations. 1, 2, 3, 4, 5. I'm reading it. You can quickly take a look, right? Then this is median. Oh, sorry, this is data set 2 and this is data set 3. Okay. So, what is mean? Who will tell me what is mean? Average. Very good. Average of data set. Adding all and dividing by total number. Excellent. Who said this? Can I know your name, please? Average is also correct, so don't worry. But who specifically who said this? Adding all numbers and divided by total. Can I know your name, please? Pungodi. Pungodi? Is that your name? Okay, great. Okay, great. Very good. You actually went one level deep and you gave the definition. Very good. Okay, so let's understand what is average first. Mm, there you go. So if I calculate the average of this first data set, there it is. Can you see? All of you know Excel little bit, right? I simply calculated the average. Then in second case, this started from 2. There were some repeated values and in the end, average came out to be 5.75. And in the third case, there were some big values in the end. So average came out to be 6.25. Okay. Now let me ask you a question. I asked you what is mean, you said average. Now if I ask you what is average, how will you explain someone who does not know what is average? I think Pungodi already did that, right? Adding all values and dividing by the total number of observations. Everyone with me? Everyone with me? Yes? Okay. dividing by number of observations, right? Total of all the observations and dividing by number of observations. Okay. Now let's go one level deep again. What are you doing when you're doing this? What are you doing when I say dividing all the values, adding all the values and dividing by this number? What are you doing? Finding the center of the data. Okay. Any more answers there? What are you doing when you are totaling all the values and dividing by number of values? Finding center of data. Alok, you are very close to the answer I am expecting. How close or how far is the data from the center? No, 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 no. You have gone far away, Gaurav. Central tendency of the data, very good. Central value, very good. So you are very close. Those who said central value, those who said center, average of total sum. See, I average was our second level. I have gone one level below. I am saying you have defined average, that sum of all the values and divide by total, divide by number of observations. I have gone one level down. Okay. So what are we doing here? Okay, let me explain. Right? Those who said finding center of the data, you were very close, but you will realize when I actually tell you what we are doing, you will realize, because center, see, when I say center, there are three types of centers: mean, median, mode. We'll see all these, right? So central value can be either of these, but in average, what are you doing? Okay, let me explain what you're doing in average. Okay, what I'll do is I'll just take this first. Okay, this is my first data set, data set 1. Okay, average. It came out to be 6. Finding the arithmetic center, sum of deviations is 0. Alok, you are very close, but you just missed something in between. Your two answers that you said, na, finding the center of the data and sum of the deviation is 0. You just missed something. I mean, explanation. Otherwise, you are very close to what I was expecting. Okay, let's understand this. So what am I doing? What is this value? 6 average. So what does average means? It means if I take the total, let me take the total of all these. Let me take it here only. Sorry. If I take the sum of all these values and I ask you to divide equally among all, that is what is average. I have taken you to the lowest level of explanation because we know what is average, but actually subconsciously we don't know. We know what is average, but this is what average is actually. Are you getting it? When I say total divided by number of observations, exactly, yes, Alicia, right? Alicia, exactly. Everyone got it now? What is average? I take the total and distribute equally among all of these. And that is what you were doing when I told you to divide by, when you told me in fact divide total by n. That is what you're doing. But we are so subconsciously we are doing the same thing. But when someone asks you, we are not able to explain. Okay? So always you will remember this now. What do you do when you do average? Okay, great. So this is what is average. Okay, let's go to the next. So that why it is, this is one of the measures of central tendency. Now a very interesting thing which Alok mentioned about this average number is, if I take the deviation of all the observation from this number, see, if I take the deviation of all the observations from this number and I sum it, this is the beauty about average. Neither mean nor mode will help you do this. This is what average is. This is the one of the most distinct feature of average, that you distribute, you take the deviation for of all the observations from this number, it will always come out to be 0. Is that clear? Is that clear? Now, then why it is coming out to be 0? Why it is coming out to be 0? Anyone? Because it means that all the numbers are equally on either side. The numbers are distributed rather, or they are dispersed equally on either side of this number, this average. This is a deviation, isn't it? This is deviation n minus x bar. Can I say this x bar, or let me put it as n minus mean, right? So this is deviation from the mean. This first number is 5 points away from the mean in the left direction, minus being the left direction and plus being the right on the right side. Okay, but when you, the wonderful thing about this average is that when you do a sum total of all these, it will come out to be 0. That is what average number is. Is that clear to all of you what is average? Let's take a look at next. Mean or median. Now what is median? All of you would be knowing this. What is median? I'm sure most of you can reply to my question. What is median? Let's see who can reply. Central number. Excellent. Who said this? No, second one. Idris. It is the center of the data after it has been sorted. Very good. Those who says middle value, okay. Those who said middle value, okay, this is my number. So, middle value, okay, this is my number. So, do you think this is median? If this is my small data, do you think this is median? No. After it has been sorted either in descending or ascending, this is my median. Is that clear? Another, again, a very important thing for median is that the data has to be sorted. Okay? Without sorting, median cannot be calculated. Clear? Okay? So let's take a look here. Though all this data is sorted, so you can see I've put these numbers in red. These are the middle two numbers. So another thing about median is, if there are odd number of observations, it is the middle value, and if there are even number of observations, like here, median is the average of the middle two numbers. I'm sure all of you know this, right? Clear? Median is clear to all of you? No confusions about median? Okay. Next. Mode. What is mode? I'm sure again many of you know this. Most repeated value, or the value that occurs most number of times. Let's take a look here. In dataset 1, can you tell me what is the mode? Look at this data. We'll talk about skewness later, Gaurav. 6. What is the mode here? 7. And what is the mode in dataset 3? 5. Very good. Okay. You can, in Excel, you can find the mode using mode function. Okay. Okay. So these are the measures of central tendency. Is this clear? What are measures of central tendency? Is this clear to all of you? Repeat median. Mehak. If two numbers are equal in numbers, matlab, oh sorry, means, so instinctly I got, if two numbers are equal in, if I could not get what you mean, what you saying, if two numbers are equal, if two numbers have equal value, are you saying this? Count of the mode, yeah, then it becomes bimodal. It becomes bimodal. Okay, it can be bimodal also. Clear? In a data set, 6 is repeated 3 times and 7 is repeated 3 times, then 6 and 7 both are mode, Alicia. It's bimodal, that's what I'm saying. Okay? That's a bimodal data. Okay? Great. Okay, let's proceed further. Okay, someone said that repeat median. Who said? Yeah, Mehak. Yeah. Okay. Mehak, median is the middle value or the average of the middle two values after the data is sorted. Okay. I have this data which is already sorted. How many observations are there? Mehak will tell. Mehak, look at the data. How many observations are there? 12. So what are the middle two observations? 6 and 6. There are two sixes. 6 and 6. Okay. These are the two middle values. Let's talk about data 3. Let's talk about data 3. What are the middle two values? 5 and 6. Okay. So median will be average of these two values. What will be the average of these two? Mac? Mac, what will be the average of 5 and 6? Nobody will answer, only Mac will answer. Now don't start calculating. Mac, I'm waiting for your response. What is the average of 5 and 6? Do you know this or not? We will divide by total value? No. We will divide by 2. Add the 2 and divide by 2. Okay? Mac. 5 plus 6, 11. 11 by 2. 11 by 2 is 5.5. Is that okay? And otherwise, what is the average of two consecutive numbers? The middle the number that is in between these two, 5.5. That is the average of middle two numbers. Okay? Is that clear? Median is clear? Perfect. So let's now understand one more concept called frequency distribution, and then we'll move to, okay, another, yeah, this, let's take a look at this example, and then we'll understand the concept of frequency distribution, and then we will come to measures of dispersion. Okay, quickly, I want you to go through this data. This is my data. Now this data is very different, is in a very different format. It says value and frequency. What do you mean by frequency? Repetition. Okay, frequency means repetition. 18 is repeated occurrence. Yeah, you're right. Right? 18 is repeated 4 times in my data. 19 is repeated 1 time. 20 is repeated 3 times, and so on. Okay? So, if you look at this, this is my complete data. Okay? And do you know what are these called? Do you know what are these called? These dashes, these tally marks. Yes, Amanatullah. Sorry, Amatullah. Tally marks. These are called tally marks. Okay? These tally marks tell you how many times this number occurred. Okay? Clear? Now, these tally marks are, I mean, of course, they are the frequency. Okay? So, let's calculate the mean for this. I'm going to repeat 18 4 times, 19, then 20. I'm going to repeat as many times these tally marks tell me, and divide by the total of tally marks. Okay, because they are the repetitions, right? So mean come out to be 26.9. Can you tell me what is the median here? These are put in order, 20 numbers, so 10th and 11th, right? 10th and 11th by 2. 20 plus 22 plus 22 by 2. What is it? 22. Very clearly, can you tell me the mode? What is the mode, everyone? 18, right? Very, very good, right? Now, if I plot this data on a number line, can you see I plotted it here? All of you can see I plotted it here, right? So this is my x. X means the data, the value, and this is fx. Fx means frequency of x, isn't it? 1, 2, 3, 4. On y-axis, I have fx. 1, 1, 2, 3, 1, 2, 2, 1, 2, 1, 1, 1, 1, 1. Right? Clear? Now, if I draw a line around this data, right? It would be something like this. Yes? That the shape that I'm going to get, that is called distribution of data. Okay? That is called distribution. Is that clear? Or you can also call it and without this, it is called frequency distribution. Okay? If I draw a line around it, it will form the shape of the data. Remember, we also study the shape of the data in shapes of the distribution, right? So A line that is formed around the data is called the distribution. Something like this. Okay? Can you see this? Fx and random variable x. Around the data, if I create a line, this is called distribution of the data. This is not, yeah, you're right. I'll come to bell curve, which is normal curve, Gaurav. But this is just, this is not exactly a bell curve also. But in the distribution of the data, you will have mode. On the, if I tell you the, if I give you the distribution of the data, the, the topmost point of this hill or of this bell will give you the mode. This will be the modal value. This is the modal value. This will be your mode because it has the maximum frequency. Can you see this? This is not normal address, near normal, right? We'll come to normal. Just hold on, okay? Because there are people, those who are doing it for the first time. Let's not jump on to normal distribution. People will get confused, okay? We are going to see normal very soon. Maybe next class, if not today. Okay? Clear? Mode is clear. Then you have mean and you also have median. Median always remains in the middle between mode and mean. Okay? Mean keeps on shifting either on the right side or on the left side. We will see when it shifts on the left side or the right side. But for those who are learning this for the first time, is it clear? Median will always be the middle. Mode will always be the point or the value that has the maximum frequency. Is that clear? That is why frequency distribution are so important, because they help you understand the shape of the data, how the data is shaped. Now, let me, now since we have done with frequency distribution, okay, I'll take an example quickly for frequency distribution and then we'll come to, okay, frequency distribution, a mathematical function showing the number of instances in which the variable takes in which a variable takes takes each of its possible values. Okay, frequency distribution in statistics is a graph or a data set organized to show the frequency of occurrence of each possible outcome of a repeated value observed many times, right? So basically, frequency distribution tell the occurrence, how much is the occurrence of this value. This is the occurrence, right? How much is the occurrence of this mean, this x bar. This is the occurrence. Okay, how many times it is repeated basically in the data. Okay, so quickly you can also calculate calculate the frequency distribution this way, right? These, let's say these are numbers from 21 to 75. Total 40 numbers are there. This is my data, right? 40 numbers are there from starting from 21 till 75 and it is sorted. Okay, this data is sorted. So to calculate the frequency distribution, first you create class marks or class rather, or what do you call this? Yeah, class only, class intervals, right? What are class intervals? You you take the minimum value, which is 21, and you take the maximum value 75, right? And then you create classes around these, right? 20 to 29 I create a class, 30 to 39 I created class intervals, 40 to 49, 50 to 59, 60 to 69 and 70 to 79. Now I create tally marks. I pick up 21. Where will it fall? 20 to 21. I put a tally mark. 23, it will fall here. 25 fall here. 27 will fall here and 29 will also fall here. So I cross this bundle of 4 tally marks with a crossed bar. Okay, and this bunch is a bunch of 5. So we cross the fifth always, so it becomes easier to count when you have, if I mean, a number of repetitions. Okay, like here, I could cross it. Let me cross this. I'll select this and I will cross this, strike through. So can you tell me quickly without reading how much is the repetition here between 30 and 39? Quickly we can easily count. You don't even have to count. The bundle, cross bundle is a bundle of 5 and plus 5 plus 3, 8. Okay, so that is why crossing is important. Clear? It's 8, right? So similarly, I have calculated the tally marks for all these class marks. So these are my frequencies, right? And when I plot these frequencies, I get a frequency distribution, which is the shape, right? When I plot these frequencies, I will get some bars like this, right? Like this one, then this one, and then when I draw a line around that, it will give me the frequency distribution. Is that clear? Right? So for, if I try to plot this, right, 20 to 29, let me quickly show it to you. So it will be like, yeah, something like this, right? Histogram, yes, I'm coming to that only, right? 20 to 29 is 5, then 30 to 39 is 8, then 9, and this is called a histogram. Okay, then 10, then 6, and 2. Okay, so something like this will be formed. This is called a histogram. So histogram is basically a frequency distribution only, right? This is my y-axis. So this is my y-axis. This is my x-axis. This is the histogram. And when I draw a line around this, joining all the middle points, okay, some, wait, so something, I draw a line joining the middle points of these, I will form a shape, and this is called a frequency. This is called a distribution of the data. Is that clear? Shape of the data is clear? Any confusion on this? Let me know, else we'll quickly proceed. Okay, great. So now we were talking about the shape of the data, right? Tell me, shape, how is the shape of the data formed? One, there is some middle value, right? If you want to analyze the shape of the data, means you want to analyze the entire data, right? If I want to analyze the shape of the data, what does it mean? I will analyze the entire data, right? I am analyzing the data, right? Now, how is this data formed? One, it has a middle value or the central value. Second, it has some dispersion or spread, isn't it? Then only this. And third, it has some height. Three things are there. One, there is a middle value, then there is spread, and third is the height. Height is not of of much importance. What is important? in understanding or analyzing the data is central tendency, which is the middle value, and even more important is the dispersion. Okay, so now we are going to understand and learn. We know the central tendencies now. Now we are going to understand the measures of dispersion. Okay, how do you measure this dispersion? Once you know this, once you measure the central tendency and the dispersion, you are able to analyze the distribution, or you are able to analyze the data in entirety. Is that okay? Clear? So let's come to measures of variability or dispersion. Measures of variability is a summary statistic. It is part of summary statistic. Summary statistic means basically uh, that gives you a summary about the data. Statistics that give you summary about the data. It includes mean, median, mode, minimum, maximum, and standard deviation, variance, and all these. Okay. So measures of variability is a summary statistic that attempts to describe the spread, diversity, variability, or dispersion in the distribution of data. Is that clear? What does measures of variability do? Now, it defines how far away the data points tend to fall from the center. This is important. That is what we try to answer when we calculate the measures of dispersion. How far are the data points from the center? It is used to identify the risk component in the data. How how many of you understood this sentence? It is used to identify the risk component in the data. Let me explain this sentence with the help of an example. I'm not just talking about outliers. Okay, here let me explain this sentence with the help of an example. I should have that example here. There you go. Okay, this is the example. Okay, I take the recording. I note down the scores or the runs scored by Virat Kohli in 5 matches, and these are the scores he scored: 59, 0, 100, 10, 40. And I recorded the scores of Dhoni: 70, 75, 80, 75, 85. Which among these do you think is more risky? Or which among these, if I ask you on the sixth match, if I ask you to predict, or I ask you, okay, how much will Dhoni or Kohli will score? Which is more risky, or which of them will be easier for you to guess? Dhoni will be easier. Virat is more risky, right? That is what dispersion measures. It identifies the risk component in the data. Okay, if you calculate the measure of dispersion here, right, we will very easily see that Virat Kohli's measure of dispersion is far greater than Dhoni's. Okay. Okay, we talk about variability in the context of distribution of values. I've already discussed this. In terms of distribution, we talk about measures of dispersion. Lower dispersion indicates that the points tend to be clustered tightly around the mean. Higher dispersion signifies they tend to fall further away from the mean. Let me show you this one. Can you see this? Blue one is having less variability because the data is more tightly clustered around the mean, which is this zero line somewhere, right? Somewhere close. Are you getting this? And for orange, lot of data falls on the extreme sides, isn't it? Hence, data is spread out in orange distribution. Is that clear? Clear? I'm going to come to this slide, which is very, very, very important. Understanding variability, understanding that variability is very important, right? We'll come to this, but quickly, okay. Lower dispersion indicates that data tends to, this is done, right? Higher dispersion signifies that they tend to fall further away from the mean. And some of the measures of variability are range, variance, standard deviation, coefficient of variation, and interquartile range. We are going to see each of these. Range. All of you know what is a range, right? And we use range very loosely in our daily lives also, or very casually also in our daily life. What is the price range of this product? We use this. What is the range of, I mean, any other, right? We use the price, we use it a lot, right? What is the range, price range of a television? What is the price range of mobile phone, right? We use it. So what do you think range is? When you say what is the range, you are saying tell me the maximum and the minimum price. Between what price range I can get the mobile phone? Okay? Are you getting this? So range is simply the difference between the largest and the smallest observation. Is that clear? It uses the most extreme observations to define the scope of the distribution. Clear? What is range? Let's again go to our data. Okay, interesting. Okay, we'll go to this data only, right? What is the range of data set 1? Simply maximum minus minimum. 11 minus 1. Range is 10, right? What is the range of data set 2? 7 and 3. 9, right? Okay, great. So range is clear, right? So to calculate range, we should know the minimum and maximum value. Okay. Now coming to variance, the most important metric in, or I would say the most fundamental metric in statistics to understand variability is variance and standard deviation both, right? So let's understand, we are going to calculate this variance with the help of this example. Okay, let's say I have measured the height of 5 dogs, 1 2 3 4 5 in millimeters. So these are the heights of 5 dogs in millimeters: 600 mm, 470 mm, 170, 430, 300. Okay, I am going to calculate and make you understand what is variance, right? Okay, before we proceed with this example, let's first understand, if you look for a definition of variance, this is the definition of variance. Anyone knows what is variance? Okay, before I proceed, anyone knows what is variance? Yes, okay, Idris, can you tell me what the definition of variance, if you know it? Those who know variance, can you tell me the definition of variance? Square of standard deviation. Okay. You have go, you have come from a different route altogether. Okay. Standard deviation is derived from variance. You are deriving standard variance from standard deviation. Okay. Average deviation from the mean. Excellent, Alok. Average deviation from the mean. Excellent. That is what I wanted, right? Measure of variability, sum of x minus r. Very good. Very good, Idris. Yes. Uh, yeah, you are right, Idris. Right? So let me first give you the definition of variance, right? And in statistics and also in data science, you are going to encounter such definitions many times. But let's straight away kill this and decipher how do you calculate these matrix, such which has definition as confusing as this. Let me read this. The variance of a set of observation is the average square deviation of the data point from the mean. You will encounter such definitions a lot in statistics. Okay, but do not get bogged down. Do not be get scared of such that, oh, it is such a long term. Average square deviation of the data points from the mean. It's very easy to calculate variance when you know this, when you have this definition, right? Start from the back and keep on adding the steps as you proceed. First, calculate the mean, then calculate the deviation of the data points from the mean, square them up and average it. You will get the variance. Did you get it? Those who are understanding it for the first time, I know people are there, those who know it. I'm asking to people, those who are understanding variance for the first time. Did you get it what I said? How do you calculate variance? Anyone who did not get it, you can just type N. I will explain it again. If you got it, very good. N. Pallavi says N. Good. Anyone else? Okay, Pallavi. The definition of variance, which you do not have to remember, okay? Because in data science, you just have to remember the concepts, not the definition, okay? It is the average squared deviation of the data points from their mean, okay? Now, how do you come up with this variance? You'll see, I will split this variance calculation into 4 steps. Starting from the back, I will calculate mean first. Second, I will calculate deviations of the data points. That will be my second step. Third step will be squaring them up, and fourth will be averaging them up. Is that clear, Pallavi? Now it is clear. I have divided this into 4 steps. Now let's quickly jump onto this. This is my data, right? First step is, who will tell me the first step? Here it is written. Calculating the mean. All of you know how to calculate the mean? Pallavi? Yes? Simply I've calculated the mean. First step, I marked it as first step. Second step, who will tell me the second step? Deviation from the mean. Pallavi, right? Deviation from the mean. Step 2, I have calculated the deviation. See? And I just discussed, can you tell me the sum of these deviations? What will be it? The sum of all the deviations? I just explained when I explained mean. Everyone with me? Right? Everyone with, I mean, those who have responded? Very good. Right? The sum of the deviations will be 0. You can see this here. Right? And that is why, see, I have got some deviations here. Right? But problem is, if I calculate the average here, what will be the average here? Can you tell me what will be the average here? 0. So I am not able to make any sense out of it, isn't it? I am not. I have deviations, but I I don't have an average deviation because the sum is mean. Sum is 0, right? That is why we do this third step, which is squaring the deviations. Are you getting it? Third step, squaring the deviations. Okay. So what did I do in the third step? I simply squared all the deviations. See? Happened. Array? Just a second. Okay. Squaring all these numbers, you can see. Right? And what was the fourth step? Taking average of them. So I have squared these numbers, squared these deviations, and then fourth step is, this is the fourth step. Step 4 is averaging. So I do a average. So I come up with this, which is 21,704. This is your standard deviation. Oh, sorry, this is your variance. Is that clear? Is this clear? Variance? Right? I'll just take 5 minutes because I just want to complete this variance and standard deviation. Then we will continue tomorrow with more topics. Okay? Okay. Now, I have calculated the variance which comes out to be 21,704. Can you tell me what are my values of x? 600, 470, 170, 430 and 300. Do you think this number 21,000 is anyways compared to this, anyways comparable to these numbers? Do you think they are at the same scale or same level? No. Why are they not at the same scale? Because this is calculated by squaring the numbers. So it is altogether on a different scale. Okay. Is this point clear? So we did calculate variance, but variance is altogether at a different scale than x. So to make to come to a number which is at least comparable and I can make some sense out of it, I add a fifth step, which is square root of this number, and that is what Alok said, I think, right? Square root of this variance is called standard deviation. See, okay, and what does this standard deviation now mean? It means on an average how much each number is varying from the mean. Is that clear? How much each number varies from the mean on an average. Is that clear? So standard deviation is that it is useful as it helps to show which heights are within one standard deviation of the mean. Okay, we'll discuss this later, right? So first, this is clear, standard deviation and variance is clear to all of you. Okay, how much is the variance? Variance was this, 21,704. Okay, when I do a under root of it, I get 147, which is standard deviation. Is that clear? Okay, let's proceed. So these are the measures of variation, range, variance, standard deviation, and one last thing we'll do, coefficient of variation, and then we'll close. We'll do IQR tomorrow. Okay, coefficient of variation. Now we know variance, we know standard deviation. Now coefficient of variation is the measure of relative variability. We use coefficient of variation when we have to compare the standard deviation of two or more samples, or when we have to compare the variability of two or more samples. Okay, All of these are more useful as they use the information contained in all the observation of the sample data set or population. See, to calculate all these matrices, right, we are using data, we are using information of all the observations, isn't it? Am I leaving any observation when I calculate variance? Am I leaving any observation? No, right? But when I calculate range, what happens? When I calculate range, I am just picking the two extreme observations. Okay? I am not at all touching what I am not at all analyzing what is happening in between. That is why these matrices, these metrics like variance, standard deviation, coefficient of variation, they are far more robust. Robust means they are far more powerful because they will not fall in any data, right? But when you calculate range, it is just picking the extreme values. Whatever is happening in between, it is not at all recording the movement in between. Is that clear? That is why, that is what this means. What this means. Okay. So quickly, coefficient of variation. How do you calculate coefficient of variation? Here it is. Coefficient of variation is the measure of relative variability. I've already told you. It is used when we want to compare the standard deviation or the variation in two or more samples. Coefficient of variation is calculated as standard deviation by mean multiplied by 100. Okay. Coefficient of variation is calculated as standard deviation upon mean by 100 multiplied by 100. Okay. Let's take an example of coefficient of variation and then we'll close today. Okay. So Fred wants to find a new investment for his portfolio. He is looking for a safe investment that provides stable returns. He considers the following three investments. So these are the three investments he considered. Forget, I mean, don't read this. I've already mentioned it here, right? Stocks, right? Stock has a mean. Okay, let me read this. Fred was offered the stocks of ABC Corporation. It is a mature company with a strong operational and financial performance. The volatility, that is standard deviation, of the stock is 10 and a mean is 14, right? Then he considers another option, ETF, exchange traded fund, which has a mean of 13 and standard deviation of 7. And then he considered bonds, which has a mean of 3 and standard deviation of 2. Now, he wants to, Fred wants the looking for a safe investment. Fred is looking for a most safe investment, right? So how will we calculate which is the most safe investment, right? We will calculate the coefficient of variation. Notice, coefficient of variation is calculated as standard deviation upon mean. Okay. Now these three numbers are the coefficient of variation. Okay. So when you have to compare multiple options, the one with the lowest coefficient of variation is the one which is giving you the most stable returns, isn't it? Is the one that is most stable. Okay. So among these, can you tell me which is the most stable? ETF, right? Though if at first instance it looks like bonds are the most safest or more stable rather, not safest, more stable return, right? It is actually the ETF which is the most stable because coefficient of variation calculates the standard deviation for per unit of per unit of mean rather, right? So among these, of ETF is the most safe option. Is this clear? The use case of coefficient of variation is clear to all of you? Okay, great then. Thank you so much everyone for patiently listening and actively participating. Very important, right? Thank you so much everyone. We'll continue our journey tomorrow same time. Till then, take care. Goodbye and just keep revising what we do every day. Okay? Thank you. Really appreciate your patience. Hopefully this session was useful and it really added value to all of you. That is very important, right? Thank you. Take care. And please, as you go, yeah, this is the first lecture. And hello, hello, hello. Wait, wait, wait. Tomorrow we do not have a lecture. Okay? Very important. Tomorrow we do not have a session. We'll have a next session day after tomorrow. Okay? Perfect. Then actually I'm not available, Amar. I am not available. So that's why. Okay? Okay, please. I will be sharing the community link. Okay? Don't worry on that. I will be sharing the community link in the next session. Okay? And I'll share all these files. Don't worry. Okay, okay. And one more thing, please do participate in the poll, in the survey. I think the survey link will be shared with all of you. I think it should be shared, right? Please do participate in the survey. Very important for us, right? Yes, it's on Wednesday. Next class is on Wednesday. Okay. Okay. Till then, take care. When you even close, you will get a link for the survey. Please do fill the survey. Okay, there is a link for the survey. Please do participate in the survey. Thank you so much. Really appreciate that. Okay, this is a link for the community forum. Sorry about that. Can we have the survey link also, Saurabh?
Yes, sir. There is a problem with the server link, but once the learners close the browser, close the session, automatically the server link will be open in the browser, so they can fill the form over there. So learners,
Okay.
please
Yeah.
fill the survey from there if you like the session, and please rate us a 5 for anything less than 5. Please share your comments and help us understand what went wrong. Yes, sir. You can continue.
No, no, fine. I'm done. Right. Thank you.
Okay, sir. So thank you, Deepak sir, for a wonderful session, and thank you, everyone, for your participation. Yeah, as I said, please go through the survey. Share your comments. If anything was less, it will definitely help us improve in the upcoming section. Thank you all for your time. Take care. Good night.
Right.